All right, so let's continue with our implementation. So last time I was running the make fixup comment to make sure that things like style and formatting are respected. I've also removed all of the print statements. Let's check whether our conversion script still runs fine. All right, so I'm gonna commit this. So if you look now at where we are in terms of steps to do, we are now at step 5, so we need to implement the model tests. So basically for every model that is available in the library, we are also testing, of course, whether these models run fine. So the source folder itself is like containing the implementations of the actual models and things like tokenizers. But then there's a tests folder, and then within the test folder you have a models folder, and there you can, for example, find the test for the Dino v2 model, which was also already created by our cookie cutter template. And you can actually run them as follows. So you can type pytest and then path to this file, and this will basically run all of the tests. But as you can see, it automatically already fails because there is an issue in the feature extraction auto file. So if we go here to models and then the auto mapping, here there seems to be an issue. Well, there is no Dino v2 feature extractor class. Feature extractors are actually deprecated because now they are called image processors. The line 330, there is an issue there. So that's at the very end. Seems that there is something wrong there. Let's see on the main branch. Not sure what happened there, but we can probably easily take this, or you know what, I'm just gonna copy everything here because we don't want to add a line for Dino v2 to this file. Then there's another issue that's in the test file itself. We are importing a class that doesn't exist. There is no masked image modeling class. So then can just remove that one. And yeah, sometimes we can just have everything on a single line, like here. Alright, let's run again. So basically a test file always consists of first a model tester class. A model tester class basically defines some hyperparameters related to the test that you want to run. So typically in order to make these tests run fast, we just test them on like very small models, like for example a Dino model that only has 5 layers, a very small hidden size, a small image size, and so on. This will make sure that the tests run faster. I'm gonna remove here an attribute that's not used. And so this model tester class will basically define like the dummy inputs that we're gonna use for all of our tests, as well as instantiating a configuration of the model. And then after that you can define like an actual test case, so a unit test.test case, which will then use this model tester class, as you can see here in its setup method. And then here we are defining all of these tests. And as you can see, every model tester inherits from the model tester mixin class, which is defined in test modeling common. And this defines like a huge amount of common tests that are being defined for all the models, like test attention outputs, which will check whether the model runs fine when you pass output attentions equals to true, test for torch script, and so on. So by inheriting from this model tester mixing class, we automatically make sure that all of those tests are run as well. Seems that a lot of tests here are failing, but those I think are all tests that don't need to be run. So let's go to the tests of the vision transformer, for example. And then here. So these are the tests for the PyTorch model, but then you also have the test for the TensorFlow model, for the Flex model. And as you can see here, this is also something we will need to do. That's actually step number 7, implementing the preprocessor tests. But that's when we get to the image processor. So here in this class, I'm gonna go to the, here we need to also define this pipeline model mapping. In this case, well, we're gonna add this later on. We're gonna add a Dino V2 for image classification later on. But for now, let's only define a feature extraction model, which is the Dino V2 model, which can be used to like turn, but there's still many things failing. Okay, encoder stride is indeed not defined. Yeah, and Dino V2 for image classification. Oh yeah, it's actually being defined here already with a linear layer. Okay, so in that case, actually, we can define the image classification here. Alright. There's still a test defined here that's not applicable for Dino V2. Model parallelism. I'm not sure. So, as you can see, we have in total 46 different tests that are being run. So yeah, here for example, this test will define the model and then run a basic forward pass and check whether the last hidden states have the shape of batch size, sequence length, hidden size, where the sequence length is defined here as the number of patches plus 1 because of the CLS token. Test CPU offload. Yeah, but these things I think are only relevant. Let's go to the test modeling common. Yeah, it's only. Yeah, this is only when we want to add like support for half precision, but I'm gonna leave that for a separate PR. And this test can also be removed because we're always interpolating the position embeddings. Alright, so note that some of the tests are marked with a slow annotated. That means that these tests are much slower than a regular test. And so actually if you run this, it will not run the slow test. So in order to run also the slow test, you need to specify the environment variable run slow equals yes. And this will also run the slow test. And in this case, we have like an integration test. So basically for every model in the Hugging Face Transformers library, we also define one or more integration tests. And these basically check. So if you go here, for example, for distal bird, there will also be an integration. Yeah, probably there is not Well, there is actually one here. There's a typo. Instead of integration, it's called integration. But yeah, those will actually check whether the model still returns like the exact same last hidden states or logits as yeah, the ones we are expecting. So basically what we can do here is we can add a push to hub flag to our conversion script. For now, I'm just gonna push them to my own user account on Hugging Face, but later on we can move those to the Facebook organization. And then here we can add, I think I already did this for another model. Yeah, this flag, a push to hub flag, we can add that to the conversion script so that we can also push like the converted model directly to the hub. So also let's use some better names like Dino V2 small patch 14, or let's just call it Dino V2 and then Dino V2 fit base 14. Let's just call that one Dino V2 base on the hub. And then we have the large variant. And the giant variant. Giant, alright. And then here we can use this name. Alright, so now we can actually run the conversion script, pass the push to hub flag. So this will basically now load. Oh yeah, we need to log in first. For that, I need to provide my token. So now we're not only converting the original model to the Hugging Face format, but also, as you can see, we're pushing the final model to the hub. So it's just calling model.push to hub here, and it will be pushed under my own user name on the hub. But yeah, later on we're gonna transfer the checkpoints. So now if you go back to the Hugging Face website, you can see it appears here. So we have a Dino V2 model here with the configuration, as you can see, and the PyTorch model. And now we can actually use this in our integration test. So here, where we're testing the actual models on the hub. So here I'm going to add a to-do comment, update organization, because I want to update this to Facebook. Then we can, for example, check here, verify the last hidden states. So this needs to be the following. And then we also want to check some expected values, similar to how we do that in the conversion script. And yeah, the Hugging Face team is basically running these integration tests for all of the models every day to make sure that, yeah, the models keep working as expected. So this is like run on a separate machine. But yeah, this is not gonna Yeah, of course, we will still have to implement the image processor. For now, I'm going to just use the VIT image processor. So let's test this again. So again, this is testing on the CATS image here, which is present in the transformers package. And it says image classifier. Oh yeah, that's because we need to instantiate here a Dyno V2 model. So let's call this just test inference no head. Yeah. Let's see whether this test passed now. And it says false is not true because there are some weights of Dyno V2 were not initialized from the model checkpoint and are newly initialized. So for some reason all of the layer scale, let's go back to the conversion script. So this runs fine and it returns like the exact slice that we need. It's pretty weird that those layer scale values are not initialized. Let's see here, layer scale. Oh yeah, I remember. This was like a super hard to track bug, but actually in the Dyno V2 layer scale class here, we are defining a gamma operator. And that actually gave issues with the from pre-train method. So I'm gonna call this one not gamma, but something else. I think I did something similar for the bait model. Lambda. Yeah, this is just, it has to do with the from pre-train method of the transformers library. Let's just call it gamma value for now. And then in the conversion script, you will see that it will work if you don't call it gamma. It has to do with Oh, here still needs to be called the gamma value. Yeah. Like you can track down this bug if you go to the modeling utils.py script where the from pre-trained. Here there's somewhere a gamma. As you can see here, load state dictionary into model. So it's gonna replace gamma by weight and beta by bias. But yeah, this is for some legacy reason. That's why it's present there. So that's why I'm gonna have to rename it here to gamma value. I've previously asked whether we can just fix this in the modeling utils file, but yeah, for backward compatibility, we're not changing that. So I'm just updating here. Okay, so now let's rerun the integration test. And it still is complaining. Oh yeah, it can just not contain any gamma because gamma is gonna be replaced by weight. Okay, let's just call it. But yeah, lambda is also probably not possible because of Python. If I just call it lambda 1. Yeah, so I'm gonna. Yeah, that's so stupid. I can just not call it. So yeah, it's now gonna work, I guess. If we just call it something else than gamma, because gamma is gonna be replaced by weight. But yeah, it's something I think we may need to really fix before merging this model. Like I'm just gonna ping the Hugging Face team again to make sure like these things can be fixed. But now there's still, yeah, but this has probably to do with the fact that we're using the VIT image processor and not the transformations defined here. So if I just test it out here, and then do the following. Because yeah, in the next video I'm gonna add the image processor class for Dino V2. Okay, now it's passing. Alright, so yeah, I'm just gonna add here to do replace by image processor class. Alright, but now I think we're there. I'm just gonna run make fix up again to clean up. So here it's not really changing a lot. Alright. And then I'm gonna just rerun the test. Alright, so I'm gonna git add this and then make fix copies. Oh yeah. Wait. Go back to. Okay, I'm gonna run make fix copies. So yeah, like it's always advised to add as many copied from statements as possible to make sure that as many classes stay consistent with other classes. Yeah, these dummy objects here, they are defined to make sure that people can import them. They are in the public init. Yeah, that's actually a bug of the cookie cutter. So if we go here to DynoV2, yeah, it's defining here these TensorFlow models, but that's actually a bug. They should not be created because you only wanted to create the PyTorch. Or maybe there was a mistake on my side when I answered the questions of the cookie cutter, because those flex classes, we're not gonna add them. Right. Alright, so we're running make fix up again. Now we need to run make fix copies again. And then we can run make fix up again. So here we're removing these. And then there are some failures still. Yeah, that's because so in the auto mapping here, there is no DynoV2 image processor class yet. So I'm gonna add that later on. And then there's still also here a DynoV2 for masked image modeling defined, but that also doesn't exist. All right, and then yeah, hidden act is actually not being used here. But I think I'm gonna check the implementation of the vision transformer. Hidden act. Yeah, I think we can define that. And also I'm gonna call this activation, that's a better name. Because they for sure are gonna ask me to change the variable name. Oh yeah, there's no config here. So if it's a string, then we're gonna... So these are all the activations that are supported. So I'm gonna check whether the conversion script is still running fine. Because we've changed quite a bit. Alright. Let's rerun the test. Well, as long as the integration test is already passing, that's already a nice thing. And let's just run all the tests. Alright, yeah, the only test that's failing is because this is not a repository yet on the hub, but that's something we will add once we transfer the checkpoints from my username to the Facebook organization. So let's say make all tests pass. Alright, so yeah, we've basically done most of the work now. So to recap, we have now finished the first 5 steps. So we have now also implemented the tests, as you can see. So tests are always located in the test models model name folder. So note actually that you can also run just test models and then the name of the folder. This will just run all the tests defined in that folder, which is pretty handy. And so yeah, note that some of these tests are marked with a slow annotator. So actually when someone opens a PR on the Hugging Face Transformers library, this is gonna run like a bunch of checks. And these checks will also run all the tests, but only the fast tests. So the slow tests are actually not being run by this CI. But all the other ones, like for example this PR, as you can see, it has 20 successful checks but 2 failing. And so one of them will actually run all of the PyTorch models, the test torch. And then you can actually click on them, details, and then see why exactly they are failing. For example, this one is not passing. So yeah, of course we require all of these tests to pass before we can merge new pull requests. So that's also something we will see when we open a pull request. But so yeah, we've now finished these 5 first steps. So then in a next video, I'm gonna implement the preprocessor class, which yeah, we can probably call DynoV2 image processor because it's a vision model. Of course, if it's a text model, then a tokenizer should be added, and so on. So yeah, see you in the next video.